Welcome to today's class. In today's class, we are going to learn implicit differentiation. Now, implicit differentiation is a form of differentiation whereby you differentiate two variables, that is both x and y, at the same time, that is simultaneously. So when you are differentiating a function implicitly, you differentiate both the x and the y at the same time. But when you are differentiating, whenever you are differentiating a y function, always put the y, the x at the back of it, okay? After you finish differentiating a y variable, only the y variable, always put the y, the x. Let us solve this question so that you understand more what we are trying to see here. Now we have to given this x cubed minus xy plus y cubed is equals to 1. Find the y, the x. So we are going to differentiate this one using implicit differentiation. So firstly, I'm going to put d all over dx open bracket everything here so that to show that I'm going to differentiate everything here. So I'll write x cubed minus xy plus y cube is equals to d dx. I will also write d dx to indicate that I'm also differentiating it. So now I'm going to open the bracket by distributing this d dx to everything inside the bracket, okay? So if I do that, I'm going to have d dx open bracket x to the power of 3 close bracket minus d dx open bracket xy close bracket plus again d dx y to the power of 3 is equals to d dx open bracket 1. So I just distributed the derivative sign to show that I'm differentiating everything here, okay? Now I'm going to differentiate I'm going to differentiate this first one. If we differentiate x to the power of 3, remember when you are differentiating using power rule, you bring down the power, so you are going to bring down 3, you have 3, then you write x as it is, then we subtract 1 from the power, so 3 minus 1 is going to be 2. So we are left with 2, so we have differentiated this one. Now we are moving to differentiate this one, so we write minus. Now I'm going to write open bracket because we are going to do two things here, because you can see we have x and we have y. So we are going to differentiate x first. After we finish, then we'll differentiate y. So first let's differentiate x. If we differentiate x, we know it's going to become 1. If we differentiate x, it's going to become 1. So we have y here. So that 1 multiplied by this y. So 1 multiplied by y is written as y. So we'll write y. Okay, that's left. We'll write plus. Now we have differentiated x. Now we want to differentiate y again. So if we differentiate y, we know it's going to become 1 also. So then we have this x left. So that 1 multiplied by this x is going to be x. But because at this point we differentiated with respect to y, we are going to write dy dx. Is that understood? We differentiated this one with respect to y. So it gave us 1, and then we'll multiply by this x is going to become x. But because we differentiated with respect to y, that's why we are writing dy dx. Remember I told you anytime you differentiate with respect to the y variable, you write dy dx. So from here I will now close the bracket plus I will now move to this one. So now we have y to the power of 3 again. So if we differentiate this one, we'll bring down 3, then we'll write y and subtract 1 from the power, which will become 2. So but now because we differentiated y, a y variable, we will write dy dx just like the way we did here, okay? So it's equals to, now we are going to differentiate 1. If you differentiate 1, it's going to become 0 because 1 is a constant. So this becomes 0, alright? So this is what we have here. Now what I will do, I want to open this bracket here so that I will distribute this minus sign. So if I do that, I will have 3x minus y minus x dy dx plus 3y squared dy dx is equals to 0. So what I'm going to do from next is to collect like times. Collect like time in such a way that those ones that don't have dy dx, will put them in one side, while those ones that have dy dx, will put them on the other side. So you can see we have 3x squared minus y. They do not have the dy, so we are going to leave this one here, while these ones that have dy, will carry them to the other side of the equation. So now if I do that, I'm going to have 3x squared minus y will be equals to, so if I carry this one out to the other side of the equation, remember anytime you're carrying a number or letter to the other side of the equation, the sign is going to change. If it is plus, it's going to become minus, but now that it's minus, by the time it comes here, it's going to become positive. So we're going to have x dy dx. If I carry this one also to this side, because it was plus, by the time it comes, it's going to become minus 3y squared dy dx. So this is what we have here. So from here again, what I want to do is to factor out the common terms between this one and this one, because all of them have dy dx, so I want to factor it out. So let us show it here. So if I do that, I'm going to have 3x squared minus y is equals to, so if I factor out dy dx here, I'm going to have dy dx open bracket. So if I remove dy dx, what we left is only x, so we'll write x minus, also if I remove dy dx here, what we left here is just 3y squared, so this is going to be 3y squared. So from here I want to make dy dx subject of the formula. If I want to make dy dx of the formula, I'm going to divide both sides by what is in this bracket, which is x minus 3y to the power of 2. So I will divide both sides by x minus 3y squared. Divide this side also by x minus 3y squared. So that means this one is going to cancel this one, and now what I'll have is that dy dx is going to be 3x squared minus y divided by x minus 3y squared. So this is going to be my final answer, and that is how we carry out implicit differentiation. Okay.